All right, so summative 8 is tomorrow, and we have 4 sections, 3.1 exponents, 3.2 logarithms, 3.3 properties of logs, and then the 2.5, the one on all the graphing, the rational graphing, okay? And, you know, I'd like to say that we don't have a lot of time to retake a lot of these, so let's be successful the first time. Does that sound like a plan? All right, so this one that I have put on here as an example of exponential graphing is kind of hard to get 3 ordered pairs on the graph paper because I have a kind of a high base here, probably not that high on the quiz, but you can just type this into your calculator, 4 to the x. You could look at the table to find some ordered pairs. There's probably, you're going to have to label a decimal one to be able to fit 3 on this graph, but exponential growth should always go through 0, 1. This one, if you put in a 1, 4 to the first power would be 4, so it should go through 1, 4. And then if you put in a negative 1, you get 4 to the negative 1, or 1/4. So since I can't really fit any other nice ordered pairs on there, I'll write that. So all exponential growth functions have as their asymptote what? Yes, the x-axis, which is y equals 0. Okay, domain and range, anybody? Left to right, what's happening? Yep, left to right, we're good. What about bottom to top, though? Yeah, 0 and up, okay? Can't hit the x-axis. And the intercept, it only had 1, and it was at 0, 1. Everybody good? Let me get that one right. All right. What if you had to take that and shift it left 3 and down 8? Do you remember how those would go in? Transformations aren't gone, guys. Yes, the left 3 would be a +3 right up here on the x. And then at the end, you'd have the -8 to shift it down 8. Think you can do that one? What if it said reflect over x and up 3? Reflect over the x-axis means it's going to go this way. Okay? It means it's going to have a negative, but where? Does it change the x's or the y's when you flip it that way? Changes the y values, so it's on the whole function. So you'd have a negative 4 to the x, and then the up 3 would be on the back. Yes? You're right. I'm wrong. I had to draw the original one. Thanks. All right. Then the next 2 on this section are applications, and really the only ones we have used so far are exponential growth and decay, continuous interest, and compound interest, okay? So those are on your little half sheet. So write in an exponential function to model the situation. In 2010, there was a population of 738 bears, is decreasing at an annual rate of 4.2%, where x is the number of years since 2010. So first write the function with x, and then figure out what happens to the population in 2021. Anybody start me out? Which of those are we using? Just this guy, yep. So the original number of bears was 738. Is it 1 plus or 1 minus? It says decreasing, so it's 1 minus. But 4.2%, what do we have to do to that? Yes, move it 2 places to the left to get rid of that percent symbol. So then you have 0.042. And then it is to the power of time. And for this part, we're going to put in what? From 2010 to 2021 would be 11 years. So if we go to the home screen, I already forgot the number of bears. Was it 9? Oh, not even close. 738. 1 minus 0.042. Did I remember that part right? To the 11th. And then it says round to the nearest whole number. So you're just looking, is this 3, is behind the decimal a half or more? It's not a 0.5 or more, so it would just be 460 bears. Questions? All right, the next one says write an expression that would calculate future value of an account with 8,200 that is earning interest or compounded quarterly. That's your hint, right? Compounded quarterly. So we are using this compound interest formula. Does everybody know what all those things stand for? Present value, rate of interest, n is number of compoundings per year, and that's going to be 12. Did this say monthly or quarterly? I can't remember. Quarterly? Okay, so for this one, n is 4, and that's n in both places is 4, and then the future value in 20 years means t is going to be 20. All right, so we have 8,200. 1 plus, what does 3.5% become? Yep, and then it said quarterly, so we divide that out over 4 compoundings per year. And up here goes a 4 times 20, or an 80. $8,200. 1 plus, I already forgot. Guys, can someone help me? 0.0 divided by 4 to the, yes. Yeah. I'm just going to go ahead and type 80. If you have an old calculator, which I would not suggest you use, you might need parentheses up there to do the 4 times 20. But does anybody not getting that number? Or did I do something wrong? Everybody okay? 16,462.57 when you round to the nearest penny. Well, let's put that down there so it's there for somebody to see later. 16,462.57. Okay. All right, now we have to graph a log graph. Normally, this would be without a calculator, and so you would want to do 2 to the x, and then flip the xy ordered pairs, because you would do the log is the inverse. And then this one has a 2 out front, okay? But as long as you can grab one of my calculators that does log base, I'm fine with you just doing that. Do you remember how to do that, though? It is, you would type 2 times, then it is under math, arrow up and find the log base, And if you have an older calculator, it doesn't have this, so you need to borrow one of mine. And then make sure it says log base 2 down there of x. Okay, if I put a 1 in there, 2 to what power is 1 would be 0, so you'd get out a 0. If you put a 2 in there, 2 to the what power is 2 would be 1, but then times that 2 out front would be 2. So I'm in my head getting, did somebody check the table? Is 2 a point? If you put in a 4, you would get out a 2 times 2 is 4, so it goes through 4, 4, I think. The next nice one would be if you put in 8, you'd get out 6, I think. I don't think I can slide that over any further. All right. But down this way, it's approaching this asymptote. I don't know, it's going off the edge of my paper, but. So the 3 ordered pairs were 1, 0, 2, 2, and 4, 4 for this one. Would that be okay? All right. So domain, anybody? Remember, these are inverses of exponential growth. So the domain and range should flip-flop from up above. This is, if we're going left to right, it's 0. Bottom to top is all real numbers. The asymptote is a vertical y-axis, which is x equals 0. And the intercept is 1, 0. Everybody okay? Be able to get that right? Is it making sense? All right, then there's a couple of transformation questions again. Reflect over the x-axis. Where would you put the negative this time? Same place, out in front, right? Reflect over x-axis is out in front. And down. Down is on the whole function, so you can write this. I would have written this to show that it's on the outside. Any questions about that one? It's not wrong if you don't put the parentheses, because anytime there's no parentheses, you assume they're only around the x. For this one, though, if you go left 2, okay, it said 2 log 2, that was the original one up here. How do you make that left 2? You have to have those parentheses to show that's inside on the x, okay? And then the up one would be on the back. Questions? All right, this is huge, guys. You have to know this, and I'm going to check your little peach sheets, make sure nobody's cheating and writing things down, because this is the one thing you have to memorize. Yes? You bet. All right, so it's log base b of a number equals the power, or the base to the power equals the number. I'm just trying to do the same way the video did. Do you remember that? So what does this one look like? Is they're going to not give you those letters? Anybody? Okay. And this one, how do we rewrite this one? Log base. What is the base in this problem? The P, and it should be a subscript, which means it's down small and towards the bottom. Of what equals what? Of M, where the answer is the power R. Got to know that. That's the whole definition of log. Okay? So then it does say on your quiz you have to rewrite what these mean. So this would mean 9 to something, and I use a little box. You can put a question mark. You could even put an X. I don't care. 9 to some power equals 9. So that answer is what? 1. This one would mean 4 to some power equals 1 over 256. Well, you could use your calculator. What is going to make it 1 over, guys? A negative. But then what power of 4 is 256? Is it 4 to the 4th? Somebody, okay. So again, we did 4 to the 4th and got 256. So then the fact that it was in the denominator made this negative 4. Okay, this means 4 to what power equals negative 64? Can you take a positive number to a power and it's going to suddenly become negative? No, you cannot take a log of a negative number. And there's one on the quiz, I think, that's not possible. So this one means 2 to some power is 1. What would that be, guys? 0. Now, I'm not taking your calculator away, so you can type these in and figure out what they are, right? Because you have a log-based button. This one would have given you an error. But you're supposed to be able to do these without a calculator, and that's why I asked that you rewrite them so you know the understanding of what it means. 3 to what power is 81? Yep, that one's 4, positive 4. All right, how we doing? Okay, properties of logs. We reviewed this yesterday. Anything that's plus is going to become what? Multiplication, and anything that's minus is going to become division or in the denominator. Okay, condense these into a single log. This one has no numbers out in front of the log, so there's no powers we need to move. So we would write the natural log of what goes up on top? X times the quantity, a plus 4, and in the denominator, this is a minus, so that goes down in the bottom, and this is a minus, so that goes down in the bottom. I know it's weird because they're multiplication, and it said minus here, but remember, we could have taken out the negative and said this, and it would have meant the same thing. Does that make sense? It is multiplication. It's just they're both in the denominator. Just remember it has to be minus to put it in the denominator. Okay. What happens when we see a 1/2? Yes, you have to know in your head that that means the square root of m. And back here we have the square root of b. So we got rid of those 1/2s. So we have a log base 5, condense, remember, means you write log only once. Anything in the denominator, or is everything up top? Yeah, just a plain old 7 goes in the denominator here. And what are the two things that are positive so they go up top and get multiplied together? Yeah, square root of m and square root of b. I kind of hope you would know that that meant they could go under the same because they're the same square root. They're not like, but I don't care. I probably would have I will accept either answer. Yes, not an English teacher. As long as they're both square roots, they can go under the same. If one was a cube root, yes. No, actually, that would be great. B times m, m times b, doesn't matter. Yep, it's just multiplication. All right, use properties of logs to expand. Okay, I would suggest first we just get rid of all the multiplying. So we'd have log base 7 of 5, and what does multiply become? Addition. So then we have log base 7 of x. And then there's another multiply. So we'd have plus log base 7 of the fourth root of b. I just got rid of, yep, this is going to be 1/4 power. Okay, and where do the powers go again? They multiply out front. So we're going to have a 1/4 log base 7 of b. Anything else we need to move, though? I think these are good the way they are, aren't they? Log base 7 of 5 plus log base 7 of x. And everything was multiply. We just had to move that fourth root as a 1/4 and move it out front. Someone want to shut the door for us? Okay, number 17. This is the one I'm probably worried the most about. Because what do you have to remember to put both of those in the denominator? They both have to be minus. Yes. Was this just a plain old log, guys, before I scribbled on it? So it's base 10, is that right? Okay. Anybody tell me how are we going to separate this? Yep. And then it says times, so we'd have plus. Yep, then we'd have the log of x to the fourth, but the exponent can move out in front. Is it okay if I do that all at once? Okay, then these two things are multiplied, but they're both in the denominator. So you do need to do minus for both. Minus the log of 8 and minus, and I don't have room. What's that last part? Yep, it would be the log of y squared, and the squared would move out in front as a 2. Questions? Be careful. All right. This is, I don't know if you need me to do all of these, but you do have to write out how you're getting these answers, okay? It says use properties of logs to help evaluate. So if it was me, I would move the 2 out front. So I'd have 2 times 4 times, and then it's log base 5 of 25, which would be 5 to some power is 25. So that all becomes a what? A 2. So I end up with 2 times 4 times 2, which is 16. Did I do that right? This one would be easier if we just took care of square root of 16, right? Square root of 16 is 4. So then it's 2 to what power is 4, and we get 2. Remember, I'm not taking your calculator away. You can just type these in your calculator and check that you got them right. Okay. Well, maybe we do this. I don't know. Just trying to think where to write these. But this means 3 to some power equals 9. And if we move this 5 out in front here, we'll have log base 3 of 3. Means 3 to some power is 3. All right, so this is 4 times, what was the answer up here? 2. Minus 5 times, what was log base 3? Oh, whoa, 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 whoa. There's a 5 we got to move out there too, right? 2 5s. There's this 5 and this 5 up here. And then what is 3 to what power is 3? That's just a 1. So that becomes 8 minus 25 or negative 17. Someone's having a bad morning with that phone, huh? What can we do here, guys? Cube root, actually, yeah, the cube root of 64 is 4. We could just do that, or we could make it a 1/3 and move it out front. That sounds kind of painful, doesn't it? Cube root of 64 is just 4. So 2 to what power is 4? That would be a 2. So then we just end up with 5 times 2 is 10. Are these working? Is anybody making sure I'm getting these? All right. Can we just shortcut these next ones? Log base 10 of 10 is what? This would be 1. So this is 2 times 1 minus 4 times what? Times 3 times 1. What is that, guys? Negative 10? 2 minus 12 is negative 10. And what is ln of e mean? It means e to some power equals e, which would be, because remember, ln is base e, so e to what power is e? That would be 1. So this would be 12 times 1 minus 6 times, you move that 2 out front, times 1. Is that one 0, guys? Because it's 12 minus 12. Okay. All right, that brings us to the fun of rational functions. On your peach sheet, make sure you know what all of this means. Okay? How do you find domain? What does it say for domain? Yeah, we can do y-intercept first. Let's do the order it says on there. Y-intercept means put in a 0 for all the x's. So you'd get 0 minus 6 or negative 6. On the bottom, you'd get 3 times 0 plus 4 times 0 plus 1, which is all just a negative 6. Everybody good? Then it says factor, yes? How does the bottom factor? Anybody got it? The only way to make a 3x squared is what? 3 and 1. And the only way to make a 1 at back is 1 and 1. Does that give us the 4 in the middle? 3x and 1x is 4x for the middle. Okay? So now domain, denominator equals 0 makes what two values down there? X cannot be negative 1 or everybody good with where that negative 1/3 came from? All right, do we have a hole? As long as we do not have a hole, then everything from the denominator is a vertical asymptote. So we have 2 on this question. All right, top heavy, bottom, oh, let's do zeros first. I think that they're first on the sheet. Zeros are what make the top 0, so we'd get what? If I put in a 6, I would get out a 0. The top would be 0. All right, and then we have the horizontal asymptote. This one is bottom heavy. Everybody with me or not? Anybody doesn't know what that means? It was a degree 1 over a degree 2. There was an x squared in the denominator, but only an x on the top. Bottom heavy says it has a horizontal asymptote at y equals 0. Any questions about which ones are equations and which ones are ordered pairs? Okay, it is. I highlighted that here. Okay, this one says ordered pair. This one says ordered pair. This one, vertical asymptote, is an equation. 0 is an ordered pair. Both vertical and horizontal lines are equations. This one says y equals, y equals, y equals. All right. How do you factor the top? Because this one's going to come on the quiz. I'm pretty sure there's one of these. What is this called? Difference of perfect squares. So 4x squared becomes a 2x and a 2x, and 9 becomes a 3 and a negative 3, right? So that the middle would drop out. There's only two terms because this would be a 6x and this would be a negative 6x, so you don't get a middle term. All right, the denominator, to get a 2x squared, you need a 2x and a 1x. To get a positive 15 but a negative 11, you need two negatives. So then I figured out that the two negatives would be a negative 6x here and a negative 5x on this arch, so that we get a negative 11 in the middle. Everybody good? All right, so quickly, domain, x cannot equal what from the denominator? First of all, is there a whole? Because it wouldn't change the domain, but we got to know eventually. Those are not the same, right? So there's no whole. Okay, the domain is x cannot equal 3 or 5 halves, either order. Good job. No whole, so therefore those are both vertical asymptotes. This one is equal weight. What does it say for equal weight? Leading coefficient over leading coefficient. Go back to the original. What were the leading coefficients? 4 over 2 or 2? Okay, the zeros are what makes the top 0? What two things would make that top 0? Positive 3 halves and negative 3 halves. Set each one of those top ones equal to 0. Those are ordered pairs. All right, and the y-intercept we were supposed to do first. When you put a 0 into the original function, you would have gotten a what? Negative 9 on the top and a 15 in the bottom. 3 goes into both those. Negative 3/5 or negative 0.6. That's hard to read, sorry. That was negative 9 over 15 reduced. All right. Find the whole. Okay. Got 10 seconds to 15, 20 seconds to factor. How fast can you factor that? Here's a negative 21x plus 1x would be the negative 20 up top. And I get a negative 7 at the back. Here I have a positive 2x minus 7x would be the negative 5 in the middle. And the negative 14 at the back. So where's the whole, guys? What's the common factor? X minus 7. So x minus 7 equals 0 makes the whole at x equals 7. Then what do we have to do? Yes, but we reduce before we plug that 7 back in. So then we end up with 3 times 7 plus 1 over 7 plus 2. Anybody else getting 22 over 9? Which doesn't reduce, right? I don't remember that answer from the answer key. Did I do that right, guys? 7 seems right. Okay. It's just ugly. but most of them are. The whole is often ugly. It's very rare it comes out at ordered pair. All right. Or the pair is a nice number, I should say. How do you write a rational function that has a whole and a vertical asymptote? I think the one we just looked at did, didn't it? But you could make up, it's got a whole. Does that make it have a whole? Same factor top and bottom? Guys, this is totally open-ended, okay? Okay, that would give it a vertical asymptote. Could you do whatever you want up top? X plus 17 to the third power. I don't know. You could put a 4 out here. You could leave it without anything else up top, as long as it had these two and another factor in the denominator. It would be a horizontal. No, it has a vertical asymptote. A whole and a vertical asymptote. That was all it had? I'd have to think about what that looks like. You can always graph what you end up with and make sure that it would have a whole and an asymptote, but yes. All right, it does say leave in factored form, so don't do any foiling on that one. You really don't have to factor this unless you're worried that there's a hole, because it only wants the vertical asymptote, which is what? How do you find a vertical asymptote? Denominator equal to 0, so we get x equals 6. End behavior equation, why is it saying that? Because this one is top heavy, and I believe it says end behavior asymptote on your, does it say that somewhere on your sheet? Okay. And what do you do to find that? Yes, it's right down here at the bottom of your sheet. It says oblique, slant, or end behavior equation. You divide and ignore the remainder. Do we have to do long division on this one? No, we can do synthetic division with a 6, and then a 4, a 19, and a -5. That would be 24 plus 19. 43. And the rest is going to be a remainder, right? So that is a very disgusting y equals, which is already there for us, y equals 4x plus 43. Did anybody else get that? Okay. I did factor it, because it does factor, but it doesn't matter, right? All we needed was to know there wasn't a hole, so. All right. Then there's one we have to do beginning to end. Is this the last one before the, oh, nope, one more. Okay, how are we doing on time? 5 minutes? 4 minutes? Okay, I'm all right. All right, what do you notice about factoring this one, though? Take a 2 out of the top, and the bottom is the difference of perfect squares. Everybody gonna get that right? I don't know if you have to take something out on the quiz, but okay, so I factored it here. I took a 2 out, and then it factored 2, x plus 4, and x minus 1. The denominator factors x plus 1 and x minus 1. So, domain, okay, what's the order on your sheet say? Before we ever factored, we were supposed to find the y-intercept. If we do that first, because we put in a 0, we'd get 2 times 0 plus 6 times 0 minus 8 over 0 minus 1, which is -8 over -1, or 8. So it crosses the y up here at 8. Then we factor, what are the domain restrictions? X cannot equal -1 or +1. You have to find the domain restrictions before you cancel. Now there is a hole at what? At +1, there's a hole. So if we remove that factor, we have a 2 times 1 plus 4 over 1 plus 1. Anybody know what that becomes? It is 5. It's 2 times 5 divided by 2. So 1, 5 is where the hole is. One of those rare, nice ordered pair places. Okay, there is a vertical asymptote. There's not 2, there's only 1 because 1 was a hole, but there is one at x equals -1, the remaining factor of the denominator. Okay, what about horizontal? It was equal weight. Equal weight is y equals leading coefficient of 2 over leading coefficient of 1. So we get y equals 2. Okay, x equals -1 was a vertical asymptote or dotted line. It says we're supposed to label them, but all right, y equals 2 was the horizontal asymptote. All right, x-intercept, what still makes the top 0, guys? -4, right? So over here is an x-intercept. -4. All right, I have this in my calculator. I think it's this one, right? You got to put it in unfactored form with the parentheses is your best bet, okay? This is what it looks like. You can go to the table and find some ordered pairs. All right. I'm going to do that last question quick. Don't leave. Okay, Malala said this. Does it have a horizontal asymptote at y equals 4? No, it needs to be equal weight with a leading coefficient of 4, right? So I could put like a 4 and an x up there, would make it equal weight with a leading coefficient of 4. Does it have a vertical asymptote at 1? Actually, she all messed up, huh? Vertical asymptote at 1 means we need an x minus 1 in the denominator. So to make it equal weight, we could put something like this. That would work. You could make it more complicated. Okay? You could sure make it more complicated, but this factor I would be looking for, and it has to be equal weight, and it has to have a leading coefficient of 4.